So in conjecture 5, we saw that if a point is on the perpendicular bisector of a segment, then it turns out it's equidistant from the endpoints of that segment. Next, we're going to look at the converse of that, which is if we find a point that's equidistant from the endpoints of a segment, then, well, then what? So since it's pretty confusing when I just say that, I think we just need to do it. So I'm just putting a pen into my compass, and we'll start by drawing a nice line segment. So line segment AB. Now again, converse is, we're going to look at a point that's equidistant from the endpoints of a line segment. So a handy tool for finding something equidistant would be a compass. So I'm going to set my compass to some setting. It doesn't really matter what it is, just picking it kind of at random. And I'll put the point at one end of the segment, and then the other. I'm making an arc up here and an arc there. So I've got a place where they're intersecting. That particular point, that one point, is equidistant from A and B. I can change my settings. I just made it a little bit bigger. I could do this again and construct yet another point that's also equidistant from A and B. Now the distance for this point is different from the distance from this point, but both points are equidistant from A and B. I can also go down to the other side of the segment. Do the same thing. So there I've got 3 points equidistant from A and B. Now one thing I'm wondering about is, are these points all collinear? So I'll take a straight edge, line it up. Well, it looks like they are collinear. So let's make a line out of it. So what do we end up with? What is the nature of this line that I constructed using these 3 equidistant points? Let's look at the angle. Wow, that is a perfect 90 degrees. So it is perpendicular. Now how about the question, is it a bisector? And I can measure that with a ruler. I can also use my compass to capture that distance on one side and then bring it over here and see if it matches. It's a perfect match. So it turns out this is not only perpendicular, it is a perpendicular bisector. So that's what conjecture 6 is getting at. Converse of the perpendicular bisector conjecture. If a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So this construction that we did has a neat side effect. This particular point is not only the place where this perpendicular bisector crosses segment AB, it is in fact the midpoint of AB. So anytime you want to construct the midpoint of a segment, this is a great thing to do. In fact, it is the main thing you're going to be doing for a lot of constructions coming up. For example, the median. Now, the median of a triangle is a segment that connects a vertex of the triangle to the midpoint of the opposite side. So if I wanted to construct a segment from this vertex to the midpoint, I'd need to figure out where that midpoint is over there. So this is where the perpendicular bisector comes in so handy. I set my compass. Now I need to set my compass to something that's at least half the length of that side. So I've done that. And what I usually do is keep one compass setting for everything. I do an arc on both sides on the top, and then another arc on the bottom. So I've constructed 2 points that are equidistant from the endpoints of that side of the triangle. And if I lay my straight edge down across that side, passing through both of those intersections, that defines the perpendicular bisector, which also defines the midpoint. And then I can mark this accordingly. That's the midpoint. And then the median connects the vertex to the midpoint of the opposite side. So that's a median. Now likewise, you can use the same technique to construct a midsegment. Now the midsegment, and I'm just going to do this as a pretty crude sketch. I'll draw a triangle and then eyeball the rest. Midsegment is like a supermedian. Instead of going from a vertex to the midpoint, it actually connects the midpoint of 2 sides like that. So there's one midpoint on one side, and there's the midpoint on the other side. And again, to find that midpoint, you would need to do this perpendicular bisector construction to locate the midpoint. Once you've done that, it's no problem. You can make all the midpoints you want. You can make a midsegment. Then you look at that midsegment, you might notice a few things. For example, it makes another triangle inside the triangle. There's some other things to notice, and we'll be doing a lot of things later on with midsegments and triangles and midpoints on sides.